Hello, this is Elliot, and I'm here today to give you a short demonstration of the model export features that are new in the version 0.7 beta test of MOMDYN. So I have the Files app here on iOS. I'm going to show you on the folder on my iPhone. There's now this folder called MOMDYN, where with the newest version, that folder should automatically show up upon installation. At the moment inside there's a Documents folder. It's empty, and a user folder as well. Again, empty by default, but shortly here we are going to make some actual things show up in those locations. So I'll open the application. What I'm going to do, topic of this video is not going to be the model building. Rather, we're going to open one that's already been constructed and simply just show what it looks like when we export the model into that documents folder I just showed you. So here's the Drubble system, of course, Drubble being the international smash sensation mobile game for iOS and Android. I can hit the play bottom in the bottom left, which will drive equations of motion, simplify. Press play button again, and we can simulate. If I hit the report tab in the upper right, we can see these data plots showing the 4 states of the system plotted with respect to time in the simulation. So I'll come back to this in a little bit, but that's just a generation of, or a demonstration of the basic simulation. Hit play, and you can see the translational, rotational, oscillational motion of the player and stool. So very good. But now getting to the point of this video, if we tap the menu button, we now have this export button here, and we can select 3 different files that will be exported. You can see the path there, momdyn/documents/drubble. Hit the check mark, we can see the message that they've been exported. Now if we go to File, Documents, new folder created, and we can see the 3 files here. So first of all, I mentioned the simulation, the 4 states of the system plotted with respect to time that you saw a minute ago. Right here in tabular form is that very same data. So let's say you wanted to pull this off into the desktop plotting environment of your choice. That's a nicely formatted standard CSV spreadsheet file that you can do just that with. All right, so the other 2 files are Python files, so if we want to actually be able to do something with them, we have to bring up our Python editor. In this case, I'm using Py2. The reason for that is Py2 has found a way to actually implement the scipy and numpy stack into their application. That's a hard thing to do, and that was why I chose it for this exercise. Is this first file I'm going to show you, PyModel. So this is the same model that I just showed you inside MOMDYN, but this is now a batch of code that can be executed inside a desktop Python environment using pretty standard libraries. So we can see at the top the imports for sympy, scipy, and matplotlib. If you installed Python, for instance, using Anaconda, all of those packages will be pre-installed. Another way that you could do this is through Google Colaboratory if you didn't want to actually install on your machine. And if you did that, then all of those packages would be pre-installed. So we can see at the top here, initiating some basic parameters, simulation parameters, go in and creates a number of different symbols included in the system with comments giving their description. The dynamic symbols here are generalized coordinates, generalized speeds, with dictionaries there giving their initial values. There is a set of kinematic equations that explains how the coordinates relate to the speeds. Create reference frames, points, particle bodies. So we create 2 particles, player and a stool. And then a list of loads, which includes gravitational and spring loads, as well as damping loads as well. Bit of stuff in here that kind of corrects some of the data to make sure that it'll simulate nicely. If I've done my homework, this will all work in the end. Down here, creates a lambdafied equation. So to those familiar with like a ODE solver in which solve IVP is the preferred one for Python. This creates the equation in the form a function of time and states x that returns a list of the derivatives of those states. And then at the bottom we can see it will simulate and plot, and then at the end save a figure called states.png. I want to grant access of Py2 to the folder that includes this script. And if I hit play, downloading scipy scripts. That's a new one. All right, well, it seemed to run anyway, so let's check out, did we get a states plot? Yes, indeed we did. So you can see with matplotlib, it simulated and then plotted the same set of states that we saw in MOMDYN to remind you here inside MOMDYN, we have the positional states at the top and then the speed states at the bottom. Looking at this PNG plot here generated in matplotlib, you can kind of sense that they have very similar responses. Notably, within the Python script, we're using the scipy and the solve IVP function. If you're using this for professional purposes, i.e. you're generating a dynamics model and then presenting it to your managers or sponsors or whoever they may be, I highly recommend that you do this part of pulling off the model into a Python format that you can execute on your desktop environment and use those highly verified, well, not scripts, entire packages that are in scipy and matplotlib. The community has extensively reviewed those over the years, and as opposed to my custom simulator that I've put into MOMDYN, that has only one eyeball reviewing it, which is myself. And so I feel pretty good about how that simulation works, but I can provide no warranty that it will give you the correct answer each and every time. I would prefer everybody create their own Python scripts that they can read and understand and use proven libraries. So one last item that I didn't mention here is this MOMDYN model.py. I'll open this one up. And what you can see at the top here is an import of mechanism from the mechanism module, if you will. That is something that is a internal, at this point, proprietary code that I use inside MOMDYN. But the thing to note is this is the way that I save a model so that when you close MOMDYN, open it up again, you can resume your work where you started before. So the syntax is a little bit different from what you would have seen in the last script. But the main thing is each of these line items kind of describes an action that you would have taken through the front end interface when building up the model. So you can see create parameter. Just to give an example, if I open up MOMDYN, go in here to the classic menu and do create a parameter, we can say it specifies a name, a value, and description. Same thing here, now just in Python keyword argument syntax. So this particular code basically reflects the action that you would take in the front end interface. Number of different line items doing similar things. So the key takeaway with that is if you wanted to, for instance, share your model with another user and then have them be able to manipulate it, you could have them paste that MOMDYN model right there and then go back into the application, import, and now we can see there's a file down there at the bottom, user MOMDYN model. In this case, it would be the same thing that we saw before because it's the same model that we exported. But that can be very useful, I think, for those of you who want to use this application collaboratively with others in your group or peer organizations. That should be something useful to you. I'd like to find a way to share those models directly inside the application without having to go through the files interface to do it, but at least this demonstrates that there is a capability to do such a thing. Anyway, so that wraps it up. Hope you'll find this useful. To me, I felt like this was a very big step of connecting what I do on the mobile application front with what I think a lot of us would like to do in terms of applying this to either our academic or professional work. So if you have any questions, please respond to the comments below or send me an email. If you have friends who might be interested in joining the beta test of this application, please feel free to share, and have a great day.